AB Calculus Section 1.3, day number 2, with a focus on inverse, exponential, and logarithmic functions. Our objectives today in this video are logarithmic functions in change of base, as well as how the logarithmic function relates to the exponential function. So a logarithmic function for any base b greater than 0, with b not equal to 1, the logarithmic function with base b is written in this form: y equals log base b of x. Okay, so this is the inverse of the exponential function b to the x equals y. Okay, so the inverse of the natural exponential function with base b equals e is the natural logarithmic function. So that logarithm, we don't write the actual base e like this, log base e of x. We actually use this notation here, that is the natural logarithm of x. It's just base e specific. Another specific logarithm you'll see without a base is log x. This is the common log, which is base 10. So it's as if that were base 10. How do the domain and range compare between exponential and logarithmic functions? So let's look real quick at specifically e to the x and ln of x. So e to the x is an exponential function. Okay, it's got a horizontal asymptote here at y equals 0. It goes through the point 0, 1. Another point is the point 1, e. And a third point would be the point -1, 1 over e. That is the function y equals e to the x. Its domain of, we'll call it domain of e to the x, is all real numbers, and its range of e to the x is 0 to infinity. Now, if e to the x and natural log of x are inverses of each other, then we know that the domain of natural log of x would be the same as the range of e to the x, which is 0 to infinity. And the range of the natural log of x would be the same as the domain of e to the x. So what would a logarithm look like? Well, instead of having a horizontal asymptote at y equals 0, it'll have a vertical asymptote at x equals 0. It'll go through the point 1, 0 instead of 0, 1. And it'll take this shape. So this will be the point E1, and this will be the point 1 over E negative 1. All right, so you can see how those two are inverses of each other. The same would be true of any log of base b. Let's talk about a couple of the properties of logs. So as we move down here are some rules using logarithms. We can expand log base b of x times y to be log base b of x plus log base b of y. The log base b of 1 is actually equal to 0, and the reason why is because b to the 0 is equal to 1. So logarithms and exponentials are inverses of each other and can be flip-flopped in form to help you to identify maybe what's going on. Now you can pause the video and see how many of these properties you can get through on your own, but I'll just keep going. Log base b of b is 1 because b to the 1 equals b. Log base b of b to the x is equal to x because b to the x is equal to b to the x. Now where am I getting these? Let's talk about that. So this is b to the 0, this is b to the 1, and this is b to the power of x, right? Where this is just an exponent. So a logarithm, in essence, is just an exponent. And it ends up equaling what's called, in this case, in some cases, the argument. That's how you take a logarithm and put it into exponential form. Okay, let's look at the rest of the properties here. When you have the division of the inside of a logarithm, so log base b of x divided by y, That's similar to the product rule we had over here, but with division we subtract the logarithms. We keep the base the same. We take the log base b of x minus log base b of y. Now a useful property here with this logarithm in the next case, log base b of x to the z, is that we can pull a power out of a logarithm and bring it out as an x, or as a coefficient of the logarithm. It's useful. We'll see it show up here in a little bit. This property here, b to the log base b of x, if this base and this base match, and the coefficient out in front of the log is 1, then you can reduce it all out and that becomes x. In a similar way, natural log of e to the x, those also reduce out. That becomes x. So those two properties are big ones. You'll see them show up on occasion. Okay, last one. Log base b of 1 over y. Well, that's equivalent to log base b of y to the negative 1, which is equivalent to negative log base b of y. And this shows up a lot, mostly in multiple choice questions where you could see multiple forms of a logarithm. Okay, so the change of base formula. Sometimes it doesn't technically matter which, well, it doesn't technically matter which base is used, but there are practical reasons for switching to, let's say, base e. Your calculator and just a lot of the, how should I say it, some strategy. It's more useful to have the natural base, which is base e, as opposed to base 10 or base 5 or something like that. So change of base formula, if I want to change log base a of x to base b, what I do is I simply, and we're not going over the proof of why, is I can then just take, and I could change this to any base I want here, right? I just take the ratio of log base b of x over log base b of a. I shouldn't have used green there. I already used green. How about blue? That's good. And again, you can choose whatever base you want, any base. So it could be base e, it could be base 10, whatever is most applicable to the situation you're working with. Okay, let's look at the next slide here at some properties and solving for missing values within logarithm. All right, so let's look for and solve for x in each of the following questions here in example 1. So log base 4 of 64. My first natural instinct, and yours should be, to put this in a form that makes sense to you. Now, if you don't know what log base 4 of 64 really means, I would put this in exponential form, and it'll help you to see what that really means. And in this case, you could do this a number of ways. If you just knew, right, that 4 to the third was 64, then you're done. If you didn't know that, what you could do is you could write this as 2 to the 2x, right? That's 4 to the x, is equal to, what would that be? 2 to the 6th. Now, since I have the same base, I can set the exponents equal. And so x would have to equal 3. That's another way to solve. Okay, again, this logarithm I'm going to put in exponential form, which would be 3 to the negative 2 equals x. That's going to be relatively easy to work with. That'll be the same as 1 over 3 squared, which means that x would equal 1/9. Okay, in the third one, part C, this written in exponential form would be e to the 5th. And I would call it good right there. It says without a calculator, so I'm going to leave it in exact form. If I had a calculator, I would just go ahead and do that out to 3 decimals. Okay, part D, in exponential form, x to the third is equal to 8. You might know that that answer is 2, or maybe you don't. But if you put 8 into a form that's applicable, then it looks like x must equal 2. All right, now we have an exponential function. I'm going to put it into logarithmic function in order to solve it. But first of all, think logically. 5 to the first power is 5. 5 to the second power is 25. So the answer is going to be somewhere between 1 and 2. But I'm going to use logarithms. And in order to write this as a logarithm, I'm going to identify the base. The base is 5. I'm going to identify the value, which is 18, and that's going to end up equaling x. So log base 5 of 18 is equal to x. That's the reverse operation for taking now a exponential, putting it in logarithmic form. Okay, let's do the same thing here for f. That would be log base 8 of 17 is equal to x plus 2. When I isolate x, that means x would equal log base 8 of 17 minus 2. In exact form, that's good enough. All right, the last one, log base 2 of 10 is equal to negative 3x plus 7. So x would equal, excuse me, it looks like I'm going to do a little work. 7 minus log base 2 of 10 all over, it looks like 3. Now, I skipped a couple steps in there. Just confirm yourself that you know why that is what it is. Notice that I didn't simplify this further because 5 and 18, those don't work when it comes to exponentials. 8 and 17, same thing, and 2 and 10. So I'm pretty good there, and I think we're solid. Let's move on to a couple of multiple choice questions. All right, the first multiple choice question says, which of the following has a range from 0 to infinity? Well, let's knock off the ones that I know for sure are not true. Well, the range of a natural log, the range of that is all real numbers. So that's out. The range of e would be from 1 to infinity, so that's out. Tangent, that's out. Its range is all real numbers. Now I'm down to a and b. I mean, you might already have made the strategic decision that b is your answer, and you're right. We're working with exponentials here. Why wouldn't the answer be exponential? But why isn't a correct, right? A is out, and the reason why is because its range, you got to pay attention to small details within these problems, is inclusive of 0. And here in the question, we're not including 0 in the range. So a is out, and our answer is b. All right, let's move to the last example here for this lesson, and then we'll see you in the next video after this. It says, simplify this expression. Now, I would encourage you during any of these videos to pause and to attempt these questions before watching, and just, isolate your mistakes, figure out how you could be better on the next example. I'm going to continue. Okay, so I have 6e to the 2 natural log of 4 plus 3. I'm going to use some properties here. First, I'm going to do this. I'm going to take the 6 out, simplify things slightly, and I'm going to use this property. All right, and we didn't really cover it in this lesson, but e to the x plus y is equal to e to the x times e to the y. That's coming from the last lesson we did, okay, on 1.3 day number 1. So I just split using that. That got me where I am now. Now I'm going to use this property. Let me see how I want to write this. How about a times log base b of x is equal to log base b of x to the a, where a in this case is going to be that 2. All right, I'm going to bring that up into the exponent, e to the ln of 4 to the 2 times e to the 3rd. So why does that help me? That helps me because now I can do this. This is e to the ln of 16 times e to the 3rd. And now I can use this property. E to the ln of x, we know, is equal to x. Just like a to the log base a of x is equal to x. So using this property, I can now say that this is equal to 16. And I think I'm ready. I think I'm ready to go. What is 6 times 16? That's 96. E to the 3rd, let's see if we've got that available to us. Why, yes, we do. And there it is. Get familiar with your properties of exponents and logarithms. They will be, I promise you, foundational and useful later on. We'll see you in the next video. Have a great day.